In this video, we're going to learn about barometers and manometers, which are used to measure pressure. So a barometer works as such. Imagine a cylinder that's vacuum sealed. There's absolutely nothing in it, including air. And we take that cylinder and we invert it, and then we put it under the surface of some mercury, and then we allow it to open up. We pierce the seal, and mercury is allowed to come up into it. Now, in general, fluids are going to be level because gravity sort of pushes them down and causes them to level out. But if there was a vacuum in the cylinder, then what happens is atmospheric pressure will push down on that mercury and cause that mercury to go up the cylinder and essentially sort of minimize this vacuum. And so it depends, of course, at how strong atmospheric pressure is, exactly how high up the mercury goes. But the standard that we have for 1 atmosphere of pressure, sort of our standard pressure, is 760 millimeters of mercury that can be measured, where if you have atmospheric pressure pushing down, then the mercury goes up 760 millimeters into the vacuum cylinder. Now, a manometer could be in two different varieties. There's a closed and an open end. In a closed end, we also have a vacuum on one end of it. And if there was absolutely nothing on both ends in this sort of chamber that would normally hold gas and the closed end, then what would happen is that the level of the mercury would be the same. Maybe this is down a little bit further to about here. Maybe this is up a little bit further to here. And we'd have the mercury level on both sides because gravity pushes down, and there's no reason why one side should be higher than the other. But if there's any gas in the manometer, it will be pushing, and that force will be pushing the mercury downward on this side, and it will cause the vacuum space to diminish. And because there's nothing pushing back, whatever the height is, that height difference between the right side and the left, that is equal to the pressure that the gas is exerting to push down. So if we had, for example, 300 millimeters of mercury as our pressure that's pushing outward here, and there's absolutely nothing pushing back, then we would notice that this height would also be 300 millimeters. Now, on the other hand, there's such a thing as an open-end manometer. And that's when, instead of having a closed end with a vacuum seal, we do have it open. And that means that atmospheric pressure will be pushing down on the mercury on this side. And that will be opposing the pressure that's pushing outward from the gas that's in the flask. So if we have a case where the difference is such that the level is higher on the left towards this bulb, then it means that whatever is pushing out is going to be less than whatever the atmospheric pressure is pushing down. Atmospheric pressure is pushing down harder, and that's why we can see the level is higher on the left side. So in that case, the pressure of the gas here that's pushing outward is going to be equal to whatever atmospheric pressure is minus that height gap. And so if we say, for example, that atmospheric pressure is 760 millimeters of mercury, and that gap right here is, say, 20 millimeters, then we can say that the pressure that the gas is exerting is going to be 740 millimeters of mercury. Again, this force coming out here is equal to 740 millimeters of mercury. On the other hand, if we find that the level is higher on the right, where the atmospheric pressure is on that side, then we can say that, well, if atmospheric pressure is also 760 millimeters of mercury, but the pressure of the gas that's pushing out is greater, and we can see that based on the left side being lower, then maybe if this is, say, 30 millimeters of mercury, that is the height here, that gap, then we have 30 plus 760 is the gas is pressing with 790 millimeters of mercury. And we can see that coming out here. That's our 790 millimeters of mercury of pressure. So that's all on this. Hope the video has been helpful. Feel free to leave any questions or comments in the comment section below, and thanks for watching.